Hello all. Today the class will be sent to you as a video in which we are going to see what is a data type in Python, how can you give expressions, what do you mean by expressions, and what is mutable and immutable types. So we are learning what data type is first. A data type defines the type of the data a variable can hold. In a program, you will be handling different types of data. The data may be in the form of an integer, it may be in the form of some floating point numbers, it may be a complex number, it may be a small character, a single character, it may be a string, a lengthy string, it can be in the form of sequences. In Python, we have lots of sequences. We will learn them very soon. So sequences, list, tuple, dictionary, anything. And if there is no data present, you will be representing it with a special literal called none. None literal, we have seen that already. So none is a special data type which represents the absence of data. So any kind of data can be handled in a Python program. So what is the type of the data a particular variable is now holding? This is actually we are going to talk about. For example, in a normal programming, if I am having x is equal to 100, then what it means is x is 100 is now referenced by a name x. X is a name that we are given to the data 100. Okay, so 100 is an integer data, right? What is the type of this data? Integer. It is an integer. And if I am creating another one, y is equal to say Priyanka. Priya. So it is a name which is a string which need to be written inside a single quote or a double quote. A string is written always inside a single quote or double quote. So what is the type of the data now y has? The type of the data is a string. Okay. So to get the type of the data, we have a special function in Python. The function is type. Inside the bracket, you can just give x or y, whatever. So whatever the value x holds, let it be integer, let it be string, let it be any of the type, even if it is none, it will show you the type of the data. So data type is important because when you use the data, you should know what type of the data you are dealing with. Okay. Now operations can be performed on these data. That means integers allow certain kind of operations. Strings allow certain kind of operations. So depending on the data type, there are certain operations we can have on these data. So we are going to see some of the data types allowed in Python. On the screen you can see that the data type in Python, the first type is number. Numbers. Numbers are, it can be integer, floating point, complex numbers. We have already seen what they are in literal. And we have sequences. Sequences means a group of data. They are stored as a sequence in a one after the other or as a group, you can say. A special structure is there. And string is a sequence. We have two other things, list and tuples. We will learn about them. List are sequence of data written inside square bracket and comma separated. Any kind of data can be written inside. That means it can be a string, integer or whatever be the data. It can be mix and match also. You can create a list like this. Okay, tuple is similar, but you write the data inside the parenthesis. Okay, tuple is a sequence of data you write inside a parenthesis. It can be 5.5, 6, A, B, C, D, E, any of these. Comma separated data, sequence of data. Okay, these are sequences. Then mapping data. Mapping is happening, it is just like indexing. That means checking the index, you will know where the explanation of a particular topic is. Similarly, it has a mapping. Key is mapped with the data, with the value. So every value has a key in it. And in list and tuple and string, the sequencing is done with an index here. Okay, a subscript is there. That means 0 points to the first value, 1 points to the second value, 2 points to the third value. It goes on until the number, how many values are there, that much number will be there. Number of sequencing is happening there. But in mapping, there is no such sequencing. We have these keys referring the data. These are the references to the data, these indices or the subscripts. These are the references to the data in a list, tuple or list, and tuple or string. In dictionary, instead of having these kinds of references, we have mapping. A value is mapped to the key. Key is paired with the value. This is how it will be. Each key is paired with a value. If you want to access the value, you have to refer the key. That is it. But in list and tuple, if you want to access a value, you have to refer the index. Okay, in the order. The third number will be index 2. Okay, this is like that. Key can be any value. It can be an integer, it can be string, it can be floating point number also. Okay, and value can be any of that. Any value can be given. Then we have the special data type none and sets. Set is similar to the sequencing, but it is not in our syllabus, so we won't learn sets. A sequence of data, a group of data taken together is actually set. Now we have this none. We will be using none. None is a data type which indicates absence of value. Now we will move to expressions. Expression is a combination of constants, variables and operators. An expression is a combination of constants or individually also. An expression can be, for example, if I am writing 10, this is an expression. If I have a variable a, this is an expression. If I am having a plus 10, this is an expression, and operators are also included in the expression. Okay, and any combination of the operation, this is also an expression. So any constant, variables and combination of all these, they will form an expression, and each expression evaluates to a value. The expression that we have written here, if we have given the value of a, this will evaluate to a particular value. Suppose a is equal to 5, then this expression will evaluate to 15. That is 5 plus 10, 15. So every expression will evaluate to a value. So example of an expression are given here. 23 minus 2 divided by 3 star 4. Okay, first we multiply 3 into 4, then 2 divided by that number, then 23 minus whatever be the result coming. So we learned the precedence of operation. This is applied here for finding the result of an expression. Precedence of operator is applied here to find the answer. So examples of the expression are given here already. Now we are moving to a special topic, mutable and immutable values. Mutable types and immutable types in Python. Here some type of the data can be changed in the same memory location. Some type of the data can be changed in the same memory location. But some values are not changeable. If you refer or if you name another value or if you change a value, a new memory location is created and the reference is given to there. I'll give you examples of that. Here the mutable and immutable means that mutable types are changeable in the memory location. The same memory location can be changeable, the type of the data in it, okay? Depending on the type of the data, the value can be changed. Which all value can be changed? If it is a list, you can change. If it is a dictionary value, you can change. The other basic types are not changeable. So immutable type. Immutable type is if you have created a memory and reference with it with a name, for example, x is equal to 10. Now 10 is referenced by this name x. If you change x to x is equal to x plus 5, the result is 15. The same memory location where we stored 10 will not be changed to 15. 15 is stored somewhere else. This location is now referenced by x. Okay, same memory location of 10 will not be changed to 15. A new memory location is created with the value 15 and that memory location is referenced by x now. This is what happens in the case of integers. That is why integer is an immutable type. Another example is string, and tuple is also immutable. You cannot change the value in it. So simply if you can change the value, it is mutable, it is changeable. If you cannot change the value in the same memory location, it is immutable, not changeable. Okay. With an example, I have given the immutable type. Assignment, that means we are referencing now x equal to 2, means the memory location 2 is now referenced by the name x. Okay, so this will create a value referenced by x. A value is created, now the value is referenced by the name x. Okay, that is what happens when you assign something like this, x equal to 2 in Python. Now in the program somewhere else, if we want to change the value of x by x equal to x plus 5, somewhere else you are changing the value x equal to x plus 5. So what happens is this same memory location will not get changed. This is fixed and you cannot change this location because it is an integer value. Let it be there. So what happens is, we know that x plus 5 is 7, right? X equal to 2, x plus 5 will be 7. So a memory location where 7 is stored is now referenced by x without changing the old location. Okay, without changing the value in the old location, this one. So what happens is, here the integer data is not changeable. If you are trying to reference to some other location, it will point to there, not the same memory location changeable. This is why integers are immutable, not changeable. The figure itself shows the meaning of immutable, that word immutable here. Okay. So what is mutable type? Let us see what is mutable. What will happen if it is a mutable type? So we know that list is a mutable type. List is a sequence, we will learn very soon. List is a mutable type in Python. List is a sequence actually. And if we have a list, I told you list is a sequence in which data is stored inside this, represented inside the square bracket, and each value is comma separated. It can be 10, 11, 20, 13. So comma separated values are represented inside the square bracket. This is what a list is in Python. This is how you represent a list in Python. So if you have created a list like this, L equal to list of 1, 2, 3, 4, 5. So this list in memory, this is actually not a single memory, a sequence is created. A sequence is created. Zeroth location will have 1, first location will have 2, second location will have 3, third location will have 4, fourth location will have 5. So this is how a sequence is created. And This is our, let's imagine this is our list in memory. So if I want to add a value to the list, it is possible because list is mutable. You can add a value to the list and still the same memory location will get changed. That's it. So what happens is we are changing it L equal to append 8. Append is a function, a method of the list which helps us to add one more value to the list. Okay, sequence of value. If you want to add one more value, you can add it like that. So append is the function we use to do this. So if I am adding append 8, 8 is added to the same memory location, and in other case what happened, a separate memory was created here with 1, 2, 3, 4, 5, 6, 7, 5, 8. If it was an integer or mutable kind of, immutable kind of location, it would have happened if you try to append it. Okay, or create a new value, add a new value, this would have happened, but this will not happen. The same memory location is get added with a new value, and the same memory location is get referenced by the variable L here. Because list is mutable, you can add a value to it. Okay, so this is the basic concept of mutable and immutable data types. Similar to list, you can change the value in the dictionary. You can add value till it points to the same place. That's it. And I would like to show another example. Okay, this is a special application. You can use this online Python tutor website for live programming, and the speciality is that you will see the memory getting created here. On the right side you will see that the memory getting created. So the first statement we are executing here is the first one, a is equal to 10. So what happens if a is created? See, on the right side you will see that a, the global frame, a is now 10. Now what I am doing is b is equal to a. So b, the variable b will now have the same value a. Okay, now what happens is I am creating a list with the values 1, 2 and 3. So a list is created x with the value 1, 2, 3, and on the reference you can see that the indexes are created from 0, 0, 1, 2. Okay, the sequence is created. Now I just copied the same value, same list to the another variable y. Now you can see two statements here which I commented, and I am removing that comment so that that line will get executed. I am just changing b is equal to b plus 5. So what happens is a and b still had the same value, and I changed the b to 15. It is a different memory location actually pointed by that value. Okay, so b is now changed, a has not changed at all, because I made the change in b equal to b plus 5. It changed to 15. Okay, a different location has been created there. Now if I am appending a value in the list x, the same memory location is referenced by y also, and because of which x and y will get changed now. If I add 5 to the list x, this is the same location pointed to by y. Why? Because list is mutable. You can have the change in there, and location, two variables are pointing to the same location here. You can see that point here, pointer. X is also pointing to this location, y is also the same. So if you make a change in x, Y is also changed. Okay, so this will happen if you change in list, and this will happen when you make the change in the integer value. This reflects difference between the mutable and immutable type of data. So that is all to learn today. We learned about the data types, what are the different types of data a Python program can have. Then we learned about expressions and expression evaluating to a certain value. And we learned about changeable and not changeable values in Python. They are called mutable and immutable. Very important. The basic data types like integer, string, floating point, tuple, these things are immutable. You cannot change into the same memory location. A new memory location will be referenced by the name if you change it. Mutable means the same memory location can still be changed. You can make change in the same memory location. That is mutable type. So list and dictionary values are mutable. So this is a small explanation of what we have already learned. Thank you.